We're going to work on an ALEKS problem that deals with calculating the pH of a strong base solution. In this example, a chemist dissolves 722 milligrams of pure sodium hydroxide in enough water to make up 160 milliliters of solution. Calculate the pH of the solution when the temperature of the solution is 25 degrees Celsius, and be sure to have our final answer in the correct number of significant figures. So the first thing I want to do is have a balanced chemical equation. So when sodium hydroxide dissolves in water, it breaks up into its cation and its anion. I want to make sure that this equation is balanced, which it is, and I want to continue with listing my given information. The problem gives us the mass of sodium hydroxide. We have the volume of our solution, which is in milliliters. I want to convert that to liters. And they're asking about pH. Now, pH is the negative log of the concentration of H3O+. So we're going to have to somehow go from sodium hydroxide to moles of OH- to concentration molarity of H3O+. So the first thing I want to do is convert my sodium hydroxide into moles of OH-. 1 milligram is equal to 10 to the negative 3 grams. Grams is in the numerator, so I need grams in the denominator. The periodic table will give us the molar mass. Now I'm in moles of sodium hydroxide. I can go ahead and take a look at the balanced chemical equation. From the coefficients, I see for every 1 mole of sodium hydroxide, I have 1 mole of hydroxide. Now that I have moles of hydroxide, I can go ahead and solve for the molarity. Molarity is just moles over liters. This is not my final answer, so I don't want to round off here, but if this were to be my final answer, I would have had to round off to 3 significant figures. So I want to keep that in mind, but because this is not my final answer, I'm going to take this out a digit or 2 till I get to the very final answer. Now that I have concentration of OH-, I can go ahead and determine the concentration of H3O+. Remember that Kw is equal to the concentration of H3O+ times the concentration of OH-. Kw is a given number. Okay, now that I have the concentration of H3O+, I can come back to my pH formula, which is negative log of the concentration of H3O+. Now we want our final answer in the correct number of significant figures. Concentration would have had 3 significant figures, and 3 significant figures in concentration means 3 decimal places in pH. So our pH is equal to 13.048. Let's take a look at another example. In this example, a chemist dissolves 283 milligrams of pure barium hydroxide in enough water to make up 110 milliliters of solution. Calculate the pH of the solution when the temperature of the solution is 25 degrees Celsius, and be sure that our final answer has the correct number of significant figures. So let's start off with a balanced chemical equation. When barium hydroxide dissolves in water, it will break up into its cation and its anion. Want to make sure that the equation is balanced, which it is. Now I want to continue with my given information. I have 283 milligrams of barium hydroxide. The volume of the solution is 110 milliliters, which equals to 0.110 liters. And I'm asked about the pH. So again, pH is the negative log of the concentration of H3O plus. So I'm going to convert from barium hydroxide to hydroxide. From there, I'm going to try to find the concentration of H3O plus. So let's start off our conversion. I'm going to convert milligrams of barium hydroxide to moles of hydroxide. One milligram is 10 to the negative 3 grams. I'm going to go ahead and find the molar mass using the periodic table. Now I want to do a conversion between moles of barium hydroxide to moles of hydroxide. I take a look at my balanced chemical equation. For every 1 mole of barium hydroxide, I have 2 moles of hydroxide. So that comes from the coefficients in the balanced equation. Okay, so now that I have moles of hydroxide, I can go ahead and find the concentration of hydroxide, which is moles over liters. This is not my final answer, but if it were to be my final answer, I would have had 3 significant figures based on my given information. But I'm going to take this out a digit or 2 and keep going with the math. Now that I have the molarity of OH, I can go ahead and find the concentration of my H3O plus. Kw is equal to the concentration of H3O plus times the concentration of OH minus. I have Kw. Now that I have my H3O plus, I can go ahead and plug that into my pH formula. pH is negative log times the concentration of H3O plus. Our concentration would have had 3 significant figures. So 3 significant figures in concentration means 3 decimal places in pH. So the pH of this solution is 12.473. Good luck and keep practicing.